This is a quick summary of all of the functions that we've graphed in the grade 11 U course. We're going to start with the parabola quadratic function. Starting with the parent function. Parent function is y equals x squared. I'm going to zoom in on the graph here. The coordinates are, the vertex is at 0, 0 on the parent function. And then from there, 1, 1, negative 1, 1, 2 and 4, negative 2 and 4. So there's the parent function. Now we use that to get our transformed function. First thing we have to notice about the transformed function is that the vertex comes from these numbers here. So our vertex of our transformed function is negative 5, negative 1. We're going to place that first. Once you have the vertex placed, the rest should fall into place very easily. You look at your a value. Our a value is a negative 2. Since a is negative 2, that means that it's going to be opening down, and it's going to have a vertical stretch of a factor of 2 as compared to the parent function here. So a vertical stretch of a factor of 2, opening down 2, if you use a step pattern, you can follow the step pattern. Doesn't matter how you place your points, but you should be able to graph this one pretty easily. Remember that it's symmetric, so once you get one point, the other one's just going to be on the opposite side. And we connect the dots with a smooth curve. And there's our transformed function. If you need to press pause to go over this again, go ahead. We're going to go on to the next slide though. Next one we're going to look at is the square root function or the radical function. Just like before with the last one, we have to start with the parent function. Parent function here is y equals root x. So these parent functions you need to be able to graph really quickly and really easily. You can sub in coordinates in your head if you need to. So if I were to sub in a 0 here, when I do that I'll get a 0. So I'm going to have the coordinate 0, 0. Now to make it easy on myself when I'm graphing the radical function, I'm only going to sub numbers in here that are easy to do. So I could sub in a 1. If I sub in a 1, the square root of 1 is 1. I get my next point. Continuing on here, the next value I'm going to sub in for x is going to be a 2. So if I sub in a 2 here, that won't work. It'll work, but it's going to give me a difficult decimal to work with. So I want to choose numbers to sub in here that are going to work out nice and easily. So the next one will be a 4. When I sub in a 4 for x, I get a 2. So I just realized that I forgot to put a scale on there. That's not very helpful, so we put the scale on so it's a little easier to see when we graph, and I put on the coordinate 4 and 2. The next one in the parent function here, again subbing in a value that we can easily work with. I'm going to sub in a 9. My next coordinate when I sub in a 9 is I get a 9 and 3. That's about all I can fit on here. So that is my parent function, square root function. So there's two ways we can do it now. We can graph our transformed function, that's this one right here. We can graph our transformed function similar to the way that we did the quadratic function on the previous screen. We can start with what we can call as our vertex. It's like the starting point, and we're just doing the positive square root. In this case it would be the 2, and 1. So I can go ahead and put those on. Right about there. But then graphing the rest of it is hard because I have an a value of 3. So what you can do is you can try and imagine taking this vertex, moving it from here to here, and then taking all the points you had originally that we already put on here and transforming them one by one with an a value of 3. Or we can use a coordinate chart. Alright, I'm getting kind of crowded in here, so I had to zoom in. The coordinate chart, we've done this lots of times in class, starts out like this, and here we have our parent function here, which is just square root x, and we put some coordinates underneath here that we came up with when we graphed our first one. So 0 and 0, 1 and 1, 4 and 2, and then we could have done maybe 9 and 3. And what you do with your coordinate chart is you take your values from up here, the A, K, D, and C. We don't have a K in this one, but we have an A, a D, and a C. Just going to move this down a bit so you can see the square root sign. My A is a 3. My D is a positive 2. And my C is a 1. So we're going to fill in these coordinates all the way across here. 0, 0, put in all the coordinates, get your answer, and you're going to do that right now. I want you to press pause for a second to figure this out on your own, and when you press play again to resume, you'll see the answers in there. So here's what our chart looks like. The first thing I did was an A value of 3, and the A's only affect the Y. So I took all my Y values and I multiplied them by a 3. That's all I did. Next column, the D. This is my D value, and the D affects the X, so my X is all changed. I added 2 to all of my X values. Last thing was my C value. C is a positive 1, which is going to lift the graph up 1, which is a vertical change. Lifting up 1 means I changed my Y values by adding 1 to them. So the Y value that I had here, each one of them had 1 added onto it to get to the new point. Take a look at the chart, see if it matches what you did. I'm going to try to zoom out now, and then we'll put our points on. So placing the new points on the graph, I'll go with yellow. So 2 and 1 we already had. We got that over here. We already got the 2 and 1. It's already on the graph right here. So I'm just going to put on the rest of these coordinates right here. 3 and 4. 6 and 7. 11 and 10. I can't really fit that on. Let's take a guess. And then we draw a curve starting at what was like what a vertex was in a parabola. It's our initial point there. Drawing a smooth curve to come out. Don't forget the arrow on the end. And there's our transformed function. Here's our third one, and I'm going to show you yet another method, another way to graph transformations of functions. First of all, as always, you start with your parent function. Our parent function is y equals 1 over x. And the reciprocal function is a little more complicated because it has asymptotes. So asymptotes, remember, are horizontal. In grade 11, we've got horizontal and vertical lines, which our function approaches, never touches, but gets infinitely close to. So we want to put those on first because that kind of establishes our boundaries for where our graph is going to fall. There are asymptotes. Our horizontal asymptote is the line y equals 0. Vertical asymptote is the line x equals 0. To get some more coordinates from our parent function to put in here, I just sub a few numbers in my head. I know I can't use 0 down here. By subbing in for a denominator, sub in a 1, for example. If you sub in a 1 for x, you're going to get a 1 for y. So we have 1, 1. The larger number I sub in coming across this way, if I sub in a 10, I'm going to have 1 over 10. Alright, so I had to go and throw in my intervals. I forgot to label my axes. So again, what I was saying is over here, if I subbed in a 10, 1 over 10, put a point there, I can't even graph it. 1 over 10 is so small I'm just going to put a dot really here, right here. It's not low enough, but that's, you get the idea. Same thing in the other direction now. If I sub in number right in here, see I sub in a half. When x is a half, if you put a half in here, 1 over 1/2 is 2. So in this case I'm going up. And we discussed this in class, so I'm just going to, from here, draw my curve, what it's going to look like. Approaching the asymptote but never crossing over on the one side. Now let's go to the, let's get some negative numbers and sub in some negative numbers and see what happens. If I sub in a -2 here, sub in a -2 for x, I'm going to get 1 over -2. So now the neat thing about this program that I'm using here is I can put in a little number, like I can sub in an x value of -8, sub in an x value of -8, and I can zoom right in there. When I sub in an x value of -8, I'm going to get I'm going to get 1 over -8, -1/8. So let's just try and put a little dot on there. -1/8 would be about maybe there. So I'll just zoom it back out. So we can go ahead and draw the second portion of this function. So that's a very rough sketch of the parent function, the reciprocal function. Now we're going to try and do these transformations on it. And we've got another way, another method of graphing transformations right now that I'm going to show you. Let's move this over a bit, get some more fighting room. So looking at the question we've been asked to graph here, we've got an a value, a k value, a d value, and a c value. So putting those all together in kind of, I think what we called in class was like a coordinate equation. A normal coordinate has an x and a y. So what we're going to do is write two little mini equations like that. But one's going to transform the x, the other's going to transform the y. So to transform the x, first of all, if I look up here, I have to do my k value first. This means divide by 2. I'm going to take my x value and I'm going to divide it by 2 if I'm doing my transformation. So I write that as x over 2. And then this is subtract 5. So that's my x, my new x coordinates can be obtained by subbing in from the parent function coordinates into here, the x values. I'm going to do the same to the y. This is a change in y, and this is a change in y. So since you take, this is the a value here, that'll be 3 times my, whatever my parent function y value was, and then I subtract 4. So using this big coordinate, I could take any coordinates that were on my parent function, like 1, 1. We've had 1, 1 over here. I could take 1, 1, I could take the 1 value, sub it in here, take the 1, sub it in here, and I will get my new transform coordinate when I do the math. So I'm going to put these asymptotes on right here. This is an asymptote and this is an asymptote. They're a good place to start when you have to do reciprocal functions. So this is really a -5. And I think that was a -4 before I covered that up. So that's a good boundary for you to help you to see where your new function is going to go with the reciprocal function. The next one on our list is the absolute value function. I'm going to skip drawing the parent function this time because it's just taking too much time. But I do notice here that I have not got my k value factored out. The x isn't isolated, so I'm going to have to do that first. I'm going to rewrite that as negative absolute value 2, open a bracket, x, and then I'm factoring that out. Factoring out the 2, so I have plus 2, plus 6. A good starting point here, like in a lot of other functions, is to get that vertex on there. So we're going to use these two numbers here to place our vertex, negative 2 and 6. There's the vertex. The absolute value function is really easy because once you get the vertex, you know that the branches coming off from it are linear, they're straight lines. So if you can just get 1 or 2 points somewhere on either side, then we'll know exactly where they go. I'm drawing this down because there's a negative a value in front, so that's going to point it down. Now the parent function goes like this. So we know it's going to have that V shape, but it's going to be coming down. So is it going to be narrow or is it going to be wide? This k value helps determine that. There's a couple of ways you can graph, and that's what I'm going over here, is all the different ways to graph. One of them is always to just sub in with a table of values. Not the best way to go, but here in this case it might work out because we only need a few points to sub in. So if I subbed in an x value of 1, an x value of 1 into the above equation, and you work it all out, what do you get for a y value? Think about it. So we have 1 and 0 right there. And because it's symmetrical, I don't even need to worry, as long as my math is good, I can go ahead and count the same amount over on the other side. So I went 3 over 1, 2, 3. And if you have a ruler, draw a straight line. There's your absolute value function. Transformed. The next one is a little bit different because this one is using function notation, which none of the others have used before. But you should be able to apply function notation to any parent function. So here's the parent function. This is the exponential function, 2 to the power of x. And I'm going to take 2 to the power of x. The first thing I'm going to do is rewrite it in the function notation you're used to seeing in standard notation, using these variables for my a, k, d, and c. So I'll start with a y equals, and my a value is a 3. And since this is my parent function here, this is what the f is relating back to. The f is telling you to go and look at the function, and here it is. So I put times 2, that's my base and my parent function. Everything else, this part here is all an exponent. However, my k value hasn't been factored out, my x isn't isolated, so I'm going to have to do that. I'll do that all in one step here, and I'll write my exponent as 4 bracket x plus 2, that's the exponent, and then the plus 1 is the c value, and it goes on the end. So one thing we recognize here is that our c value is the asymptote right there, and we're going to place that first. Once you've got your asymptote on there, it just gives you a little bit of a boundary to help you see where you're going, but you still need to get all the rest of the function on there. Again, I'm not starting with the parent function this time because it's taking too long, and you should already know how to do the parent function really quickly. I'm just going to do the transformation. So you can either do a coordinate chart at this point, you can do the coordinate equation that I showed you before about how to draw an equation and get points out of it, whichever way you prefer. So let's go with the coordinate chart here. A lot of you like that one. We start with the parent function, getting some coordinates on the parent function. Negative 2. Sub in a negative 2 up here, and you get 2 to the power of negative 2, which is not negative 4. Over 4. So I want you to do the rest of these here. press pause and finish these up. Okay, so the next step now is to get all of these. This is an A, this is a K, this is a D, and this is a C. So your next part now is to fill in the rest of your coordinate chart with those values and work your numbers across. So now that you've got your A, K, D, and C listed, remember that it's okay to have these two in a different order and to have these two in a different order, that's all right. But it is important that you do your A and K before you do the D and the C, so you have to keep those pairs in mind. You can obviously do K and D together, A and C together if you're doing the coordinate. That's what you would do. Once you have this part of the chart set up, now it's just reminding yourself of the steps that need to be done. So here, the A value means you take your Y value and you multiply it by 3. The K means you take your X value and you divide it by 4. D value is taking your X, it's a horizontal change, so it's taking your X value, subtracting 2. And your C is a vertical change, so it takes the Y, this affects your range, and you add 1. So go ahead and fill in your chart, please. Alright, check with your answers with mine and see how they look. Remember, fractions are accurate, decimals are approximate, but when you're dealing with 1/2 or 0.5, it's the same thing, it doesn't matter. And when you're graphing, even if you had a third, it's just as impossible to accurately graph a third as it is to graph 0.3, so it's not a big deal when you're graphing, whether you use decimals or fractions. So once you have your chart done, go ahead and put it on your graph. Remember that the points that you're graphing are these ones right here. Those are the ones you're putting on your grid. So what happens when you get to a situation like this and you've got 4 dots it's hard for you to see what the function is supposed to look like, especially if you don't have a good grasp of the parent function. If you do have a good grasp of the parent function, you know what it looks like. It's like this, coming up, exponential growth with the asymptote. We have no negatives, negative A value or negative K value. That means it hasn't flipped. So our parent function that was like this is not supposed to be coming down, and that's good. Ours doesn't look like it's coming down. And it's not supposed to be all of a sudden going this way, and it's not going that way. So because we have no negative reflections through the X or Y axis, we know that we're still headed in the same direction as the parent function, and that helps. If you don't have a good grasp of the parent function and you're still not sure what these dots are supposed to be doing here, they almost look kind of linear, then you can always try a few more coordinates. You can sub in a -6 and see what's going to happen when you sub that in. Or you could sub in a 0. 0 is an easy one to sub in and see where that's going to land. So you could try a few more coordinates to get an idea of what your line is supposed to look like. Another way to graph, which I'm going to show you here, is step by step, each transformation one at a time. So if you were doing that here, the first thing you would do would be the parent function. And in this case it would be y equals the square root of x. Next part would be to take the parent function, and you could do the a and k together. A and k can be done at the same time, or you can do them one at a time. If you're going to do them one at a time, you can do either one, doesn't matter. Maybe the easier one would be to start with the -3, the a value. So you would transform this function by applying the a value of a -3. So you're going to have a reflection and a vertical stretch. Next would be the k value. That's a -1/2 x. So again, you're taking what you already did and you're just putting one more transformation on it. So this would be your third graph on this axis. The fourth one would be the d value. So again, the rest of this is the same. Notice the k value is already factored out this time, so we didn't have to do that. X minus 5, so you're going to take your previous graph that you did here and you're going to shift it all 5 units to the right. That's what this -5 is going to do, shift it 5 units to the right. And then your last graph will be here. That'll be your fifth graph, adding on the 6, which is raising it up 6 units. Taking this one right here and bringing it up 6 units. So that's another way to graph, a longer way to graph, but it should get you to the final answer just the same as any other method. So now here's one for you to try. When you're done, you can go ahead and look at the answer. Here's your answer for the sinusoidal function. Remember, if you want to check your work, you look at your graph that you've drawn. Let's say you've just drawn this one here, and you pick a good clear point on it. Say, see if we can find one here, where you can see a good x and a y value. Maybe right here. So that's an x value of 270 degrees and a y value of 6. So what you do is you take the equation that you had on the previous screen, you sub in a 270 for the x, you're just doing math now, you're just doing some algebra, you're subbing it in the equation, you work it all out, and hopefully you get an answer of 6. If you don't, you could have subbed it in wrong, or maybe your graph was wrong, but this graph is right, so you should get a 6. That's it.